It's like everyone wants to stay on top of things, right? Keep up with what's new, what's changing. But, who actually has the time to read every article and research paper?
Yeah, it's impossible to keep up with everything.
Right. It's overwhelming. And that's where we come in. We do the heavy lifting, sort through it all, and pull out the most interesting and important bits.
So you can stay informed without, getting bogged down in the weeds.
Exactly. And today, we're digging into something pretty big in the world of AI.
Oh, yeah. This is a major development.
Meta just released their Llama 4 family of AI models. And this is not just a minor update. It's a pretty big step forward.
Yeah.
Especially when it comes to open source AI.
Yeah. Open source models are becoming more and more important in the field.
For sure. And to really understand what's going on here, we've gone through, a ton of material. We've got stuff from Meta themselves, of course.
Their blog posts, their announcements.
Yeah, all that. But also analysis from places like Databricks, Microsoft Azure.
Cloudflare, Amazon, AWS, even Grok.
Right. We've got a news report from TechCrunch, some YouTube videos from, Matthew Berman and Mervyn Prazen.
A real mix of perspectives.
Yeah, we wanted to get a good overall picture. And now, our mission is to break it all down for you.
Distill it down to the key takeaways, what you really need to know.
Absolutely. So let's jump in, shall we? Llama 4, it sounds like they released more than just one model. Is that right?
Yeah, they did. It's not just one single model. They're calling it a herd of Llama 4 models.
A herd. That's an interesting way to put it.
Right. So in this initial release, we have 3 main models. There's Scout, Maverick, and Behemoth.
Okay. Scout, Maverick, Behemoth.
And one thing that's really cool is that all 3 of these models are designed to be natively multimodal.
Multimodal, so they can handle text and images right from the start.
Exactly. They're not limited to just one type of data. They can work with text, images, and even other types of data, potentially.
Wow, that's a big deal, right?
Mm-hmm.
Most models are either text-focused or image-focused.
Yeah, traditionally. But these Llama 4 models are built differently. They're all using something called a mixture of experts architecture.
MOE. Yeah.
MOE. And that's a big part of what makes them so efficient.
Okay, so mixture of experts. I'm familiar with the term, but could you explain it in a way that, someone who's not super deep into AI could understand?
Sure. So imagine instead of having one big AI brain that tries to do everything, you have a bunch of smaller, specialized expert brains. Each one is really good at a specific type of task.
Okay, I'm following so far.
And then there's a traffic controller, a router that decides which expert brain to send each piece of information to.
So it's like a team of specialists working together, each one focusing on what they're best at.
That's a great way to put it. And that's what MOE does. It makes the whole system more efficient because you're not wasting processing power on tasks that a particular expert isn't good at.
That makes a lot of sense. So let's dive into these specific models, starting with Llama 4 Scout. What are the key things we need to know about this one?
All right, so Llama 4 Scout has 17 billion active parameters.
17 billion. That's a lot, even for a large language model.
Yeah, it is. But the total number of parameters across all 16 of its experts is even higher. It's 109 billion.
Wow. Okay, so 17 billion active, 109 billion total. Got it.
But here's a stat that's really impressive and that a lot of people are talking about. Scout has an industry-leading 10 million token context window.
10 million tokens. That's huge. I think the previous record was somewhere around 2 million, wasn't it?
Yeah, 2 million was considered pretty large, so 10 million is a massive jump.
What does that kind of context window even mean in practical terms? What can it actually do with all that information?
Imagine being able to feed the entire text of War and Peace into the model, or hours and hours of meeting recordings, or a massive software code base.
I'm picturing it.
And the AI can actually understand the connections between everything, remember details from the very beginning all the way to the end.
So it's not just remembering more stuff, it's actually understanding it all in context.
Exactly. And that opens up so many possibilities. You can have much longer, more coherent conversations with the AI. You can analyze incredibly large documents and extract meaningful insights. And just the overall depth of understanding in any interaction is just, it's a whole different level.
It's like the AI has a much, much bigger working memory now.
That's a good analogy. And Meta is even saying that Scout has, quote, nearly infinite context length in practical terms.
Nearly infinite. That's a pretty bold claim.
It is, but the 10 million token window is already a huge step in that direction.
So how does Scout actually perform in real-world tests? Does it live up to the hype?
Well, based on Meta's own benchmarks and what we're seeing from platforms like Databricks, Scout is outperforming other models like Gemma 3, Gemini 2.0 Flashlight, and Mistral 3.1.
And those are all pretty strong models, right?
Oh, yeah, those are some of the top performers in their class, but Scout is coming out ahead in a variety of standard AI evaluations.
Impressive. And they're calling it the best multimodal model in the world in its class, is that right?
Yeah, that's what Meta is saying. And what's remarkable is that it's actually more powerful than previous Llama models, but it can still run on a single high-end NVIDIA H100 GPU.
So it's powerful, but also relatively accessible.
Right. You don't need a massive server farm to run it.
And now you mentioned it's multimodal. We've talked about text, but what about its image capabilities?
So Scout has what's being described as best-in-class image grounding capability.
Image grounding. Remind me what that means again?
Sure. Think of it as the AI's ability to understand where objects are located within an image and how those objects relate to the words you're using.
So if I ask it, where's the cat sitting in this picture? It can actually pinpoint the cat's location in the image.
Exactly. And it understands that location in relation to other objects in the picture. It's not just recognizing that there's a cat, it's understanding the spatial relationships within the image.
That's pretty sophisticated.
It is. And Scout was pre-trained and post-trained with a 256,000 token context length.
Okay, so that's contributing to its ability to handle those really long inputs.
Exactly. They've shown it can find specific pieces of information within huge amounts of text, like those needle in a haystack tests.
Yeah, those are tough.
And it's successful even when you're dealing with like up to 10 million tokens. They even did some tests with 20-hour videos, and it was able to retain the relevant information.
That's incredible. So if someone listening wants to try out Llama 4 Scout, how easy is it to get access?
It's actually pretty accessible. You can download it right now from Meta's website, llama.com.
Okay, so go straight to the source.
Yeah, and it's also available on Hugging Face, which is a popular platform for AI models.
Ice Hugging Face, I've heard of that.
And beyond that, it's being integrated into various cloud platforms. So Databricks already has it available. Microsoft Azure AI Foundry has a couple of versions of Scout available.
So there are a few different options depending on your preferred platform.
Yeah. Amazon AWS has it on their SageMaker Jumpstart service. Cloudflare Workers AI is supporting it, initially with a 131,000 token window, but they plan to increase that.
Okay, so Cloudflare is a bit more limited right now, but they're working on it.
Right. And even Grok Cloud, which is known for its specialized AI hardware, has Scout up and running. They have their own pricing structure for input and output tokens.
So plenty of options to explore.
Yeah, it seems like Meta is really trying to make this model widely available.
Okay, so that's Scout. Massive context window, strong multimodal capabilities, and readily accessible. Now, what about Llama 4 Maverick? What sets it apart?
So Maverick also has 17 billion active parameters, same as Scout.
Okay, so they're similar in that respect.
Yeah, but Maverick is a much larger model overall. It has 400 billion total parameters spread across 128 experts.
Wow, 128 experts. That's a lot of specialization.
It is, and it also has a million token context length.
Okay, so not quite the 10 million of Scout, but still a huge amount of information it can handle.
Yeah, a million tokens is still a lot, and there's actually some speculation that they might increase that even further in the future.
Interesting. So what are Maverick's standout strengths? What's it particularly good at?
Maverick really excels at understanding both images and text, and it supports 12 languages right out of the box.
Okay, so very strong in multimodality and multilingual capability.
Exactly. And based on benchmark tests, it's actually outperforming models like GPT-4o and Gemini 2.0 Flash.
Really? Those are some big names to beat.
Yeah, those are some very powerful models. But Maverick is coming out ahead across a range of evaluations.
That's impressive.
And what's interesting is that it's achieving comparable performance to the DeepSeek V3 model on tasks like reasoning and coding, but it's doing so with fewer active parameters.
So it's kind of punching above its weight in terms of efficiency.
Yeah, I think that's a good way to put it. It's delivering high-end performance, but in a relatively compact package.
So that probably translates to lower costs as well, right?
Yeah, potentially. It's being highlighted as having a best-in-class performance-to-cost ratio.
That's always good to hear. There's even an experimental chat version of Maverick that's scoring very well on the El Marino leaderboard.
Right, it's placing near the top of the ranking, so it seems to be very versatile.
Okay, so what kind of tasks is Maverick best suited for? What would you use it for?
Well, it's a good fit for general-purpose AI assistants and chatbots, anything that needs to really understand images and even creative writing applications.
Some pretty broad applicability.
Yeah, it seems to be a good all-rounder.
And how about access to Maverick? Is it as readily available as a Scout?
It is. You can download it from llama.com and Hugging Face, just like Stout.
Okay, so same sources.
Yeah, and it's also available on Databricks and Azure AI Foundry. The specific version on Azure is called Llama 4 Maverick 17B128E Instruct FP8.
It's a mouthful.
It is. AWS has it on SageMaker Jumpstart, and it'll be coming to their Bedrock service soon as well.
So similar availability to Scout, it seems.
Yeah, pretty much. And Grok Cloud also offers Maverick with its own pricing structure.
Okay, so it's out there if you want to try it.
It is. But it's worth noting that running Maverick might require more powerful hardware than Scout. You might need something like an NVIDIA H100 DGX system or an equivalent setup.
Okay, so a bit more demanding on the hardware side.
Yeah. Scout is probably more accessible for a wider range of hardware, while Maverick offers those top-tier capabilities, but might need more robust infrastructure.
All right, so we've covered Scout and Maverick. Now let's talk about the really intriguing one, Llama 4 Behemoth. That name just screams power.
It does, doesn't it? Behemoth is a truly massive model. It has 288 billion active parameters and nearly 2 trillion total parameters spread across its 16 experts.
2 trillion parameters, that's just mind-boggling.
It is. It's hard to even comprehend a number that large.
And it's still in training, right?
Yeah, it's not fully trained yet. But even in its pre-release form, it's already showing incredible results.
So how's it performing in these early stages?
Well, Meta is reporting that Behemoth is already outperforming models like GPT 4.5, Claude Sonnet 3.7, and Gemini 2.0 Pro on some very challenging STEM-focused benchmark tests.
It's already beating the best of the best.
It seems so, at least on certain tasks.
That's incredible. And they're using it internally as a teacher model as well, right?
Yeah, that's right. They're using its vast knowledge to help improve the performance of Scout and Maverick.
So the smaller, more accessible models are learning from this giant, still-in-training behemoth. That's a fascinating approach.
It is. It's like they're using the big brain to train the smaller brains.
Exactly. So any idea when we might see Behemoth actually released to the public?
No official word on that yet. It's clear that they're positioning it as one of the most capable LLMs in the world.
And it'll probably require some seriously powerful hardware to run.
Oh yeah, definitely. But its existence and the early results they're seeing, it really gives us a glimpse into where AI capabilities are heading.
It's exciting and a little bit intimidating at the same time.
I agree. Now, thinking about all these models, are there any specific architectural innovations that are driving these advancements?
That's a good question. Is it just about making them bigger, or is there more to it?
There's definitely more to it. One key innovation is their approach to multimodality, which they call native multimodality with early fusion.
Okay, break that down for me. What does that mean?
Essentially, they're treating text, images, even video as a single, continuous stream of data right from the start.
So it's not processing the image separately and then trying to connect it to the text later on.
No, it's integrating it all from the very beginning.
And that makes sense.
And that allows the model to learn the relationships between different types of data much more effectively.
There's a more holistic approach.
Exactly. They've also incorporated an improved vision encoder, which is the part of the model that handles image processing, and that's based on their Metaclip technology.
Okay, so they're building on their existing work.
Yeah. Another interesting development is a new training technique called MetaP, which they're using to set all the hyperparameters for these massive models.
Hyperparameters, those are like the settings that control how the model learns, right?
Exactly, and there are a lot of them, especially with models this big. It seems like this MetaP technique is helping to make the training process more efficient and consistent.
Okay, so that's on the technical side. What about language support? We know Maverick supports 12 languages. What about the other models?
So the entire Llama 4 family was pre-trained on a dataset of 200 languages.
200 languages, that's incredible.
It is. That's 10 times more multilingual data than they used for Llama 3.
Wow, they're really pushing the boundaries here. And they're using something called FP8 precision during training, right?
Yeah, that's a technique that allows for more efficient computation without sacrificing the quality of the model.
So squeezing more performance out of the hardware.
Exactly. And they're also using something called IROPE, which is an architecture that helps with handling those really long context lengths.
So it's a combination of scale, smart engineering, and efficient training techniques that's leading to these impressive capabilities.
It seems so. It's not just about making the models bigger, it's about making them smarter and more efficient.
Now let's shift gears a bit and talk about the practical side of things. How easy will it be for developers and businesses to actually use these models?
Well, running the very large models like Maverick and certainly Behemoth when it's released locally, that's going to require a lot of computational power.
Yeah, I can imagine. Not everyone has a supercomputer sitting around.
Right. It's probably not going to be feasible for standard consumer-grade hardware.
But Scout might be more manageable, right?
Yeah, Scout might be accessible for systems with a lot of memory, like some high-end workstations, maybe even powerful Macs.
Okay, so there's some hope for local deployment of the smaller model.
Yeah, potentially. But I think the main way most people will interact with these models, at least in the near term, is through cloud platforms.
So the big cloud providers like AWS, Azure, and so on are going to be key to making this technology accessible.
Absolutely. They're the ones with the infrastructure to handle these massive models. And as we've discussed, AWS, Azure, Cloudflare, Databricks, they're all making different versions of the Llama 4 models available on their platforms.
Right, we talked about that earlier. And Grok Cloud is pushing their specialized hardware for running these models.
Yeah, they're emphasizing the performance and cost benefits of their platform. And of course, Meta themselves are integrating Llama 4 into their own products like WhatsApp, Messenger, and Instagram.
Right, through their Meta AI assistant.
Yeah. Yeah. So while having these models running directly on your laptop might be a ways off, the cloud makes them accessible to a much wider audience.
It sounds like a pretty exciting time to be working in AI.
It is. There's so much potential here.
Well, this has been a really fascinating deep dive into the Llama 4 family. I feel like I've learned a lot. To quickly recap, Meta has made a significant leap forward in open-source multimodal AI.
That's a great summary.
They've got these incredibly large context windows, impressive performance across a variety of tasks, and they've made some smart architectural innovations to improve efficiency.
And they're making it all accessible through a variety of platforms.
Exactly. The potential impact across different industries is huge.
Yeah, it's hard to overstate how significant this could be.
So as we wrap things up, here's a final thought for you to consider. With these advancements, particularly the massive increase in context window size and the native multimodality, what entirely new AI-powered applications do you think might now be possible?
It's a great question to ponder.
It really is. We encourage you to explore these models further. Maybe try them out on Hugging Face or one of the cloud platforms we mentioned.
The possibilities are endless.
They really are. Thanks for joining us for this deep dive. We'll catch you next time.